Okay. All right, y'all might be wondering why I drew this little box up here. It's because I've tried so long and for so long and so many times, and I can't get rid of the glare because I do not have a camera. I don't have a camera stand. All I have are a bunch of textbooks and an iPad. So I can only get so nerdy within 1 year, so I only have a limited amount of textbooks, which I can use to stack all of these up for the iPad. But basically, it's just to indicate that there's glare from my ceiling light. So yeah, I'm not gonna write there. But what are we gonna do today? So before I go on a tangent here, so I'm gonna verify the work-energy theorem, which is work is equal to the network is equal to the change in kinetic, right? So I am actually going to derive the equations of motion using this and a few other helpful boys right here. So bear with me. I promise the equations that I pull, they're going to be like, oh yeah, I definitely know what that is. So here we go. So we know work is also equal to force times some displacement, right? So we substitute that in. And we know this K is a change, right? So it's the difference between the final K, the initial kinetic energy, right? And the formula for kinetic energy is 1/2 mv squared. And substitute in 1/2 mv final squared. So I'm just going to indicate that this is the final kinetic energy with the subscript here on the final velocity. Minus 1/2 mv naught squared. Similarly here, v at times 0, right? So what are things we can do here? We can factor out the 1/2 m. And what is F? So you're probably going to ask any person that doesn't take physics, they'll know F equals ma. It's iconic, right? Shout out to my boy Newton. So substitute that in. So there's an m here, there's an m here. We divide both sides by m and get rid of the m. So this is a critical line. This is like the changing point. This is like the point of no return right here. We're about to go into kinematics. You notice there's just velocity, acceleration, and displacement. It's kind of feeling kind of 1D motion vibe, right? So this is where the magic happens. So we're going to start by multiplying both sides by 2. Then, if you add v naught squared to this side, I'm going to rewrite it like so. V naught squared plus 2a delta x, right? I just flip-flopped. The equality still holds. And that's our third equation of motion, or like I remember it in terms of like order on the formula sheet. But like, yeah, that's an equation of motion right there. So that's true. But wait, there's more. So what I want to do, starting from this line right here, I want to derive the other equations of motion. So we're going to go back to this line. And, okay, so let's start from here, right? 2a delta x. So what is this? This is the difference of two squares, right? So we can write that as the sum times the difference. Whoa. All this algebra trick in the book. Now, what is this delta x? So if you recall, velocity is equal to the change in position, displacement, over time. Right? So we're cool here. So if we multiply both sides by t, you'll get this. Ah, what do you know? Now we can put that in right there for delta x, right? So let's see. Vt, AVT is equal to V final plus V naught, V final minus V naught. Check the glare. Yep, glare's not in the way. Okay, perfect. So now, what is this V? So this V, since it's algebraic, it's going to be the average velocity, right? And we know that the average is the sum over the number of terms. So average velocity, we're just taking it at 2 points, the final velocity plus the initial velocity divided by 2, right? That's a definition for average stuff and teams, right? So we can put that in there. So A, V final, there we go. is equal to this. Okay. Because of order of operations, you notice I almost like pulled the 2 out completely, but I can pull this 2 out. Right? Whoops. I dropped a 2 in here somewhere. Right? We started from this line. So 2a, 2a. I hope I didn't lose anybody right there. But basically, if I pull this 2 out, there's a 2 here and a 2 on the bottom on this side. So those 2's goes away. So we're left with AT, V final, plus V naught is equal to V final plus V final minus V naught. And you see here, we divide both sides by V final plus V naught, and they go away. So AT is equal to V final minus V naught, and there we go. That's another one. So we add V naught to both sides. I'm going to flip flop it just for style here. There you go. That's another one right there. So what can we do with this? Well, how about we go from this line right here, or not? You know what? I'm going to be good to you guys. I'm going to stick with this line right here. So we're going to pull from this line again. So 1/2 V final squared minus V naught squared. All right. So now we have this definition for final velocity. There's a final velocity right here. So guess what? We're going to stick it in there. So I'm going to indicate this with square brackets here real quick. Okay, so, well, it's a FOIL problem. We're going to multiply out this bad boy right here. So it's going to get a little bit messy with the algebra, but don't worry. We're going to be okay. So this is going to be V naught squared plus 2 V naught AT plus A squared T squared minus V naught squared, right? So if you FOIL this out, it will become like this. There's a little trick. X plus Y squared is equal to X squared plus 2XY plus Y squared. Yeah, that's what I did here. But basically, you run through the algebra yourself. It's going to come out to this. And you notice there's a V naught squared here and a minus V naught squared here. So those are going to go away. So 2 V naught AT plus A squared T squared, right? So if you actually carry out this fraction here and go in, multiply everything by 1/2, look at this. AT plus 1/2 A squared T squared. Last but not least, if you divide everything by A to get this delta X by itself, you are going to get delta X is equal to V naught T plus 1/2 AT squared. And there you have it. Those are the 3 equations of motion derived from net work is equal to delta K. So we use a little bit of definitions, but I promise, like I told y'all, everybody knows F equals ma. Everyone knows velocities that change in position over time. So it's not like those are like completely new. So yeah, this is partly the reason why physics is like really cool. Excuse me, I'm gonna nerd out for a second, but like, y'all, all the equations are like connected, and I kind of didn't believe it until like, you know, my teacher was like, they're all connected. So I went ahead and, you know, messed around, because that's what I do in my spare time. I'm kind of a nerd, but like, yeah, it's pretty neat. So hope you enjoyed, and I ignited your love for physics a little bit more.